for day 3 notes, the sample 1 says to solve each one of these using the zero product property. And all that means is that you take each expression and you set it equal to 0. So it would look like 4a plus 1 equals 0 and a minus 2 equals 0. And then you would just solve each one of those equations. So for this one, I would subtract 1. And then I would divide by 4. And that would give me negative 1/4. Then here, if I add 2, 0 plus 2 is 2. So those are my 2 solutions to the problem. So for part B, I set this part equal to 0, 3x minus 9. And then I set the second part equal to 0. And I solve each one. So for this one, if I add 9, I have 3x equals 9. Then divide by 3. And 9 divided by 3 is 3. That's my first solution. To get the second solution, I would just subtract 6. And x equals negative 6. Okay, again, that is called, I apologize, the zero product property. So you're setting each part, each expression, equal to 0 and solving it. So this is a pretty simple explanation of how to solve these so far. Okay, then when we go to example 2, we have solve by factoring. So for these, I want to look to see, okay, is that x factor or is that bottoms up? And this is just x factor. So how would I set this up? Well, I would do 1 times 15 is 15. And I'm trying to get to 8. And the factors of 15 are here, 1 and 15, 3 and 5. So which one of these gets to 8? 3 and 5. So now I would say x plus 3 and x plus 5. So at this point, we have done this. Okay, we have done all of this. We have figured out how to factor with x factor, how to fill the puzzle in, and then get our 2 sets of parentheses. The new part is saying, if I want to solve for x, I set this equal to 0. And then I say x plus 3 is 0, or equals 0, and x plus 5 equals 0. And then I solve each section. So here we have subtract 3. That's a negative. Here I subtract 5. And that's a negative as well, so it's a negative 5. So my 2 solutions are negative 3 and negative 5. Okay? So let's try this again in part B. And we want to look to see what kind of x factor this problem is. So this would be bottoms up, because that number is bigger than 1. So I would do 3 times negative 14 is negative 42. And I am trying to get to the middle number, which is a 1. So factor sheet, if I figure out everything that multiplies to 42, okay, which one of these pairs can make 42? Well, 6 and 7 can. Sorry, 6 and 7 can make a 1 if I subtract, but multiply to be a 42. So now I got to figure out my signs. Okay, so I'm going to go with a negative 6 because 7 minus 6 is positive 1. Multiply, I get negative 42. And lastly, if you do the small number first, big number second, these two numbers need to have matching signs, so they're both positive. So now I go over here and I rewrite it in factored form. But I can't forget I've got to divide by that 3. So if I divide by 3, I get x minus 2. Here I can't divide, so I bring the bottom up. Okay, so at this point we have factored. We know how to factor bottoms up. We have done that. Now we set equal to 0. And we set this equal to 0 and this part equal to 0. And we solve each equation. So for here, x would equal 2. We would add 2 to the other side. For this one, we're going to have to subtract 7 and get 3x equals negative 7. Then we divide by 3 and get a negative 7/3. So I just wrote the 2 from here, and the negative 7/3 I brought here. As you can see, if it's a fraction, if it can't reduce, I'm just going to leave it in that fraction form.